Hey everyone, so for this video I wanted to go over scope cant, a little bit about what it is and why it's important and how it's going to affect your shots downrange. So essentially what scope cant is it's any variation in the true vertical nature of your optics reticle. So a little bit of cant side to side. So a few ways that can be induced is by the shooter basically holding the rifle not truly in line and adding a little bit of induced cant that way. But the other one is also when you are mounting your optic. So when you're mounting your optic, you want this to be essentially completely in line with the bore of your rifle. And that's because when you're making your vertical adjustments on your reticle, you are basically compensating for the gravity affecting on the bullet. So you want that to be in line with the bullet, which is in line with the bore. So you're gonna have gravity pulling down to the bullet. You need your crosshairs to be perfectly in line with that for the corrections essentially to be valid. So what happens if it's not? So let's come over here and look at a situation where the optic was mounted just a little off vertical, we'll say about 3 degrees. So what happens, you get your horizontal portion here, and when you make adjustments in your optic, it is going to track along the vertical line. So use my rifle as an example, my 6mm Creedmoor, I have got 22 MOA of adjustments at 1,000 yards. So now if I dial 22 MOA and my optic isn't truly in line with the bore, meaning I'm not doing my true correction with gravity that I need to on the bullet, I'm going to end up with a horizontal and a vertical component of that adjustment back to a little bit of trig. So what happens is now we can solve for this. So we'll do sine of the angle equals the horizontal over the hypotenuse. Now what that gives us is that's going to give us our horizontal correction, and what that comes out to be is 1.15 MOA. So just a 3 degree change in how that scope's mounted is going to result in a 1.15 shift of your bullet impact off of your correction. Now we can come back and use this and we can solve for the vertical portion. And what ends up happening is that vertical component is 21.9. So now that is very close to the 22 MOA that you dialed for. So if you're shooting at 1,000 yards, you're probably not going to notice this variation. But what's going to happen is you're going to keep getting a hit to the right in this orientation of 1.5, almost 1.15 minutes off of where you're aiming.